Good morning, student. In previous session, we studied about the introduction of the static electricity, and we studied that like charges are repel to each other and unlike charges are attract to each other. Why it is possible to attract unlike charges to each other and repulsion of the two charges between them? It's possible because there is a force applied between two charges. Due to this, like charges repel to each other and unlike charges are attract to each other. This was illustrated by Coulomb in 1785. Coulomb experimentally show that if two charges Q1 and Q2 are placed at the certain distance R, then there is a force applied between them. That means Coulomb's law illustrates that when two charges, Coulomb's law illustrates that when two charges placed at the certain distance then force of interaction that means force of attraction or repulsion between them is directly proportional to the product of the charges and inversely proportional to the square of distance between them. That means, according to Coulomb's law, force when two charges placed at the certain distance R, then force of interaction between them F is directly proportional to the product of charge and is being inversely proportional to the square of distance between them. It's being equation number 1 and it's being equation number 2. From equation number 1 and 2, we get F directly proportional to Q1, Q2 upon R square. F is equal to K Q1, Q2 upon R square, where K is proportionality constant, where K is equal to 1 by 4 pi epsilon naught. R is also equal to 9.0 0 into 10 to the power 9. Newton meter square per Coulomb square. That means value of K be 1 by 4 pi epsilon naught r. Numerically it's equal to 9.0 into 10 to the power 9 Newton meter square per Coulomb square. Here epsilon naught is known as permittivity constant of medium. If you want to take the screenshot, you may take it. Here dimensional formula of K. According to this, K Newton meter square upon Coulomb square. That means dimensional formula of K is equal to dimension of force mLT to the power minus 2, dimension of m is distance, that is L to the power 2, and dimension of C square, that means A square, which is the unit of the current, and T square. By this we can write it as m L to the power 3, T to the power minus 4, and A to the power minus 2. Its dimensional formula of K are, we may say that 1 by 4 pi epsilon naught. Here we say that the value of K, that means 1 by 4 pi epsilon naught is equal to 9.0 into 10 to the power 9. That means 1 equals 9.0 into 10 to the power 9 into 4 pi epsilon naught. Value of epsilon naught is equal to 1 divided by 9.0 into 10 to the power 9 into 4 pi, which is equal to 1 by 4, 1 10 to the power minus 9 divided by 9.0 into 4 into value of pi is 3.14. It's being equal to 10 to the power minus 9 divided by 113.04, which is into 10 to the power 2. This will be equal to, this. It's being equal to 10 to the power minus 9 divided by 1.1304 into 10 to the power 2. It's 10 to the power minus 9 into 10 to the power minus 2 divided by 1.1304. It's equal to 1, 2, 3, 4 into 10 to the power minus 11 divided by 11304. It's equal to 0.8846 into 10 to the power minus 11. It's equal to 8.846 into 10 to the power minus 12 is equal to 8.85 into 10 to the power minus 12. Its value of silent night. And its unit be Coulomb square per Newton square, Newton meter square. If you want to take a screenshot, then you may take it. After this, we may write down the dimensional formula of silent knot. Silent knot, its unit is Coulomb square upon Newton meter square. That is dimension of silent knot is equal to dimension of charge upon dimension of force dimension of square. It's be m to the power minus 1, l to the power minus 3, t to the power 4 and a to the power 2. It's the dimension formula of silent knot. By using this, Coulomb's law, F is equal to 9.0 into 10 to the power 9 Q1 Q2 upon R square. We may define 1 Coulomb if Q1 is equal to Q2 is equal to 1 Coulomb and R is equal to 1 meter, then F is equal to 9.0 into 10 to the power 9 Newton. That means 1 Coulomb is defined as when that 1 Coulomb is defined as when two charges having value equal to 1 Coulomb and placed at the distance of 1 meter, then force of attraction between them be 9.0 into 10 to the power 9 Newton. That means 1 Coulomb is defined as when the two unit charges placed at the distance of 1 meter, then force of attraction between them being 19.0 into 10 to the power 9 Newton. It's the definition of 1 Coulomb. By this, when two charges, in which condition force of attraction between charges is attractive and in which condition it's repulsive. That means when the product of Q1, Q2 is greater than 0, that means positive. Then force is attractive in nature. And when Q1, Q2 is less than 0, then force is repulsive in nature. That means by finding the product of the charges, that means you mention the sign of the charges, it may be positive or it may be negative. That means product Q1 and Q2 be greater than 0. If Q1 and Q2 both be positive or negative, and Q1, Q2 be less than 0 if Q1 and Q2 have opposite in sign. By this way, you may find the force is attraction or force is repulsion. After this, by using, if you want to take a screenshot, you may take it. Comparison between electrostatic force and gravitational force. Gravitational force between two protons. Suppose charge of proton is equal to 1.6 into 10 to the power minus 19 Coulomb, and mass of proton is 1.67 into 10 to the power minus 27 kilogram. Then electric force is equal to K Q1 . 1 × 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ proton, Q1 Q2 upon R square, which is equal to 9.0 into 10 to the power 9 into 1.6 into 10 to the power minus 19 Coulomb into 1.6 into 10 to the power minus 19 Coulomb, whole divided by R square, separation between them, and gravitational force between them is equal to G m1 and 2 upon R square, where G is equal to 6.67 into 10 to the power minus 11, m1 1.67 into 10 to the power minus 27, and 2 1.67 into 10 to the power minus 27, and distance R, the separation between them. Then may find FE divided by FG. It be equal to 9.0 into 10 to the power 9 into 1.6 into 1.6 into 10 to the power minus 38. This whole divided by R square, whole divided by 6.67 into 10 to the power minus 11 into 1.67 into 1.67 into 10 to the power minus 54 divided by R square. It be written as 23.04 into 10 to the power minus 29 divided by 18.601963 into 10 to the power minus 65 is equal to 23.04 divided by 18.60 into 10 to the power minus 29 plus 65. It's being equal to 1.24 into 10 to the power 36. That means electrostatic force is equal to 1.24 into 10 to the power 36 into force, gravitational force between them. That means electrostatic force between two protons be 1.24 into 10 to the power 36 times the force, gravitational force between them. You will take the screenshot. Importance of the Coulomb's law. Coulomb's law is applicable for the short distance and for a short distance. That means it's applicable for shortest distance. That means in order to 10 to the power minus 15 meter to 10 to the power minus 11 meter or more distance. That means this distance is for the size of the nucleus and this for the size of the atom. Size of the atom. That means you know that atom is the smallest particles of the any substance. That means it's applicable for the smallest distance atom as well as the nuclei. If you know that atoms are made up of three particles in which electrons revolve in outermost shell and neutron and protons are inside the nucleus. There is force of attraction and repulsion, both are applied inside the nucleus. Force of attraction due to mass of neutron and proton and force of repulsion due to the charge of proton. That means inside the nucleus there is two forces is applied. One, force of attraction, which is gravitational force between the mass of the electron, neutron and mass of the proton, and repulsive force between the charge of the proton. That means inside the nucleus two forces are acting, one in nature attractive and second in nature repulsive. These forces are important, take place an important role in radioactive element due to force of repulsion. Radioactive elements lose their continuous masses. If this force is not applicable or not working, in this case radioactive elements doesn't lose their weight. Their radioactivity doesn't take place. After this we will study about the Coulomb's law in vector form. After this we are going to study the Coulomb's law in vector form. Coulomb's law in vector form. Two charges here, Q1 and Q2 are placed at a certain distance r, which is R1 to R2. Then position vector of R1 Q1 with respect to Q2. And position vector of Q2 with respect to Q1 is position vector of Q1 with respect to Q2, 2, 1 in vector form, and its unit vector is R21 I. This position vector of Q2 with respect to Q1 is this one, and unit vector R12 is this. You know that unit vector R12 I cap is equal to vector 1 2 upon modulus of vector 1 2. R is may be equal to R12 position vector of charge 1 with respect to charge 2 upon R12. R unit vector of Q1 is equal to R21 divided by R21. R is equal to this divided by R21. This is the direction of the position vector and direction of the unit vector, and its direction of the position vector of charge Q2 with respect to charge Q1, and its unit. And force, there are, if we suppose that both charges are like, that means suppose they are protons, then there are force of repulsion acting between them. This. That means it's being force on particle 1 due to particle 2, and this being force on particle 1 due to particle 1. Is vector quantity. That is force F1 2, force and point charge 1 due to point charge 2 is equal to K Q1 Q2 upon R1 2 square into position unit vector 1 2. That means it shows the direction of the force. And second, force on charge 2 due to charge 1 is equal to K Q1 Q2 upon R21 square into R21 unit vector. Here, both forces are same in magnitude but opposite in direction. This force is also write as Q1 Q2 upon R21 square into R1 2. It's the minus inside because direction of 1 2 is equal to minus direction position vector 2 divided. That means force applied on charge 1 due to charge 2 is equal and opposite in direction due to force on charge 2 due to charge 1. It's Coulomb's law in a vector form. After this, you may also study about it that when Q1 and Q2 are same in sign, that means both are being positive and both are being negative, then force are equal and opposite in direction, and force nature of the force is repulsive. But when Q1 and Q2 are opposite in nature, Then F12 is equal to minus F21, which will be force of attraction between them. The both first attract second towards it and second attract first towards it. In this case also force is opposite in direction but equal in magnitude. Sorry. After this, we are going to study about the force in vector form due to multiple charge. Force between multiple charge. Force between multiple charges. Suppose it's point O. Charges here, charge Q1, charge Q2, charge Q3 and here charge Qn. Then you may find the force here. Force and charge Q1 is applied by charge Q2, also applied by charge Q3, also applied by charge Q4 and so on by charge Q3. That means its direction, force, direction of the force acting. Suppose its position vectors of the charges R1, R2, R3 is Rn. Position vector of Q2 with respect to Q1 its speed R1, 2, R1, 3, R1, N. Then force due to this is in this direction, by this direction and by this in this direction. So net force acting on F1, net force on Q1 is equal to F1 is equal to force on charge 1 due to charge 2 plus force on charge 1 due to 3 plus so on force on charge first due to n charge. Here question is arises that here 1, 2, why force due to first charge not applied on the first charge? Force applied by a charge on itself being 0. Force on charge 1 due to 1 is being 0. Due to this we will not mention it. That means if F1 force on charge first or Q1 due to charge Q2, Q3, Q4 are mentioned as 9.0 into 10 to the power 9 Q1 Q2 upon R1 2 chi square plus 9.0 into 10 to the power 9 Q1 Q3 upon 13 square plus so on 9.0 into 10 to the power 9 Q1 Qn divided by R1 n square R1 3 or you may also write as force on charge 2. It's equal to force on charge 2 due to 1, force on charge 2 due to 3, plus so on force on charge 2 due to n. It's being equal to 9.0 into 10 to the power 9 Q2 Q1 upon R21 square R21 unit vector plus 9.0 into 10 to the power 9 Q2 Q3 divided by 2 3 square 2 3 IN plus so on 9.0 into 10 to the power 9 Q2 Qn divided by 2n square r 2n and so on. By this way, you may also find the force on any charges due to the multiple charges.